All right, we are now recording, and we'll go from current slide. I'll even get my pen activated. I usually forget to do that. All right. Now, I know you've heard this, but Emmanuel and Victor may not have, so let me go through this again. This is our last day of class, okay, which means your paper was due in today, but both you and Emmanuel have already turned in your papers, okay, so that's fine. I've returned to you your first, or I have already returned to you your first test, okay? Let me just tell you this, not everybody's turned it in, so don't let it be seen, because otherwise you'll wind up cheapening your grade, okay? I do have your paper, and I have Emmanuel's paper. Here is your first test. You did extraordinarily well on it. Okay. And here is your well, somewhere here is your second test. And again, not everybody has turned it in, so please don't let it get out. Okay? I'm still missing a couple of second tests. Okay. And I'll give you your third test today. That's your final exam. Okay. You did find finally the student course evaluations?
Yeah.
Okay. So you're going to get those done?
Oh, they got now.
Oh, you're already finished?
Yeah.
Good. All right. That was awfully quick, but hopefully it was good. Okay. For the rest of you, the other two, hopefully you're listening. I need your student course. I don't need your student course evaluations, actually. I do. I don't get to see. I don't know what you do. There's no way I can tell what you do on your student course evaluation. All I see is the composite. But I need you to do them, okay, because the dean is wanting basically our percentage participation to go way up from what it's been. And it's been fairly paltry, okay? So please do your student course evaluations, all right? Please. All right, now I always throw this in on the side. What's next Tuesday? Voting, okay. Please don't forget to vote on Tuesday. For instance, I work until 8 o'clock Tuesday night. I can't go home and vote after work because the polls close at 7. So I have to schedule to be at the polls before 7 o'clock so I can vote at 7 and get to work by 7:45 because I have an exam to give at 8 o'clock. So please do whatever it takes to make sure you vote on next Tuesday. Okay? That's just a little aside. That's a paid political announcement. Except you're not paid. Okay, all right. Next, I've mentioned your papers. I've returned things to you that I can. All right, the test I'll give you today is due anytime next week. Okay? Sooner better than later, but get it to me sometime next week. Okay? Now, let me go over when I'm available. Okay? This week is a regular class week. So after this class is over with, from 3:15 to 5:15, I have office hours down in my office. Okay? Tomorrow, Thursday, regular class day, I have office hours tomorrow from 1:15 to 3:15 down in my office. On Friday, I'll be on the Birmingham campus as normal, 7:45 to 11:45. All office hours as far as I know. I sure hope they don't call any meetings on the Friday before finals, okay? That would be miserable. Okay. Now, next week, all bets are off, or most bets are off anyway. My schedule that's posted on my door is no longer valid because we're doing finals. Except that one of my classes is a mini-term class, so that means the first part of the week I'm doing the class for that, the second part of the week I'm doing the final for that. So it's really messed up. So here's what my schedule is. As best as I can tell you for next week. Monday morning of next week, from 8 till 9:50, not 9:15, 9:50, I'm running a problem session for my Math 100 class, okay? So I'll be in here doing that. I will not have time to answer questions or go over or do anything with you because I'll be running a problem period for a full hour and 50 minutes, probably closer to 2 hours, okay? I'll be in with them, okay? So if you need to turn anything in Monday morning between 8 and 9:50, just slide under my door, okay? Of my office, not the classroom door. All right. The rest of Monday is pretty much free, okay? So basically from 10 o'clock until 5:15, I should be in or around my office, okay? Now, remember I said I was running a problem period for them, problem session for them, review session. So as soon as that review session's over with, I've given them the option they can come take their final anytime they want to, okay? So someone may elect to take it right at 10 o'clock, okay? Or 12, or anytime between 10 and 5:15, or later in the week too. So that means I could be at any time giving a final. Okay, I'm not going to give a final in my office. There's not room, okay? It's too cramped and crowded and messy and stuff like that. So if a student comes to take a final, and that could be anytime, then what I do is leave my office and start looking for the closest empty classroom, and that's where we'll sit down and I'll give the final. That way I can go back and forth to my office without being out so long. I may even be able to hear my phone ring if it rings and stuff like that. So if you come looking for me after 10 o'clock on Monday up until 5:15, if I'm not in the office, check all the classrooms between there and here. Because if all those classrooms are filled, I can give it here because I'm the only one who teaches here except for Dr. Bryan. And he's Monday, Wednesday afternoon. And I think he gave take-home finals for his class, so he won't have any people in here. All right. Tuesday morning from 8 to 9:50, I'm giving a final in this room. So if you need to see me, I'm here, but it's rather not be making noise while they're trying to take a final, okay? So if you just want to drop something off, slide it under the door to my office, or if you do need to see me, I can go out in the hall and talk with you or whatever. That's 8 to 9:50 on Tuesday. All right, the rest of Tuesday from 10 till 3:15, I should be in my office or anywhere in between there and here, okay? 3:15, however, my physical science class, which has a regular class that day, we meet at 3:15. That's not a test, it's a class. So we'll be going over the last chapter. When we finish the last chapter, we'll have a lab. When we finish the lab, then they can either leave or I've given them the option of taking the final anytime they want to. The reason I did that, a lot of them are automotive students. Some of them are from out of state, and many others are from within the state but a long way away. So they have fairly long distances to travel, and mine may be their last final they have. And if so, I don't want them to have to sit around here until Thursday afternoon with nothing to do except my final. So I've given them the option. If they want to take it early, they can. So that's the other reason I may be anywhere in any room between my office and here, because not only my Math 100, but my physical science class too can take their finals anytime they want to. Okay. So that I'll be here until 8 o'clock Tuesday night. Wednesday, I have absolutely nothing scheduled, so I should be in my office or any classroom in between from 7:45 in the morning to 5:15 in the afternoon. So catch me there. My office is the first place to look. After that, try the classrooms until you get up here. If you miss me everywhere, go back to my office. I'll be back in a few minutes, okay? Thursday, anytime between 7:45 in the morning and 3:15, I should be in the office or anywhere in between, okay? 3:15 is when that physical science class is scheduled to have the final. If any student opts to come and take their final on Thursday afternoon at 3:15, that's where I'll be, right here. If they've all taken it before then I won't be here. But I'm guessing a few of them will say, no, I've got other finals, so I don't want to worry with that until Thursday afternoon. If that's the case, then I will be here in this room, 3:15. Now, the final won't take them more than 45 minutes, I don't think. So 3:15 to 4 o'clock, I should be here. After 4, anywhere between my office and here. Okay? I'm here till 8 o'clock on Thursday night. Well, yeah, I think I will be. If absolutely nobody's here and I've gotten everything done, I may leave early, but I usually don't, because I never get everything done. Okay. Then Friday of next week, I'm back on Birmingham campus, 7:45 to 11:45. Now, have you been here at Lawson enough to know about finals week? Okay. Student suite, that you can check all sorts of things on, usually gets shut down during finals week. And here's the reason. We have a really archaic old system. It only has, last time I checked, it was only 16 portals that only 16 people can be on the system at any one time. Usually that's enough, okay? But during finals week, when all the students were wanting to check and see what the grades were, those could all get eaten up really fast. And then we can't get on to put the grades in. So the students are checking the grades, but they can't see the grades because we can't get on to put them on. So the first term that happened was a nightmare, and after that they decided to shut down Student Suite all during finals week. So if you're trying to look at Student Suite during finals week, don't even bother. It's not going to work. But I and most other instructors put the grades on Blackboard and do all the averaging and everything there before we put it on Student Suite. So Blackboard is always open. So go to Blackboard and check your grades. There's no reason to go to Student Suite next week during finals week. Okay, now grades are usually due by noon the Monday after finals. So that will be not this coming Monday, but the following Monday by noon. That means I've got to have all the work in next week, because I don't have time on Monday morning to grade 15 papers and put all the averages in and get everything done by noon. I just don't have time. So get it in next week. Everything in by next week. Okay? Now, last term, something screwed up. I think it was Blackboard. So they gave us an extra day. But there's no way we can guarantee that unless you hear that grades are not due until Tuesday at noon. If they are, then I can take something else on Monday, but not Tuesday. Okay? But get everything in next week. Okay? So up until grades are due, Student Suite will be down. They'll be down all during finals week and up until whenever grades are due. Okay? After that, then you can get on Student Suite again. All right. I think that's about everything. I can't think of anything. Do you have any questions? All right, let's pick up where we left off last time. We're in Chapter 4, Higher Order Differential Equations, 4.3, Homogeneous Linear Equations with Constant Coefficients. Example 3, middle of page 138, is a third order differential equation. We started to do this and then realized we were out of time. Here it is, y triple prime plus 3y double prime minus 4y is equal to 0. Okay? Now, where would you begin?
Well, you'll have to probably say, I think it's y is equal to e raised to mx.
Y equal e to the mx. That's your first guess when you have higher order differential equations, linear and constant coefficients. If you had a variable coefficient, don't do it, but constant coefficient. Then y prime is equal to m e to the mx. Y double prime is equal to m squared e to the mx, and triple prime is equal to m cubed e to the mx. So what does your differential equation become then? Okay, e to the mx
times m cubed plus 3m squared minus 4 e to the mx.
Okay, yeah, equals 0. Okay? Now, what can you tell me about this?
That it doesn't equal zero.
Never equals 0. E to the mx cannot equal 0. It's always greater than 0. Maybe not by much, but it's always greater than 0. Okay, so that means the only possibility is that part. However, that's a cubic equation. Okay? M cubed plus 3m squared minus 4 equals 0. Okay? I can't factor that. Okay? It won't work by factoring by grouping because you don't have even number of terms. Okay? It looks pretty dreadful, doesn't it? Okay? Well, I don't know if you remember rational zeros test.
No.
Okay? What that goes when you have a higher order polynomial equation, all your possible rational zeros will be of the form of P over Q, where P is any factor of your constant term, which would be plus or minus 1, plus or minus 2, or plus or minus 4, right? Over Q, which are any of your possible factors of your leading coefficient, which is just plus or minus 1. So, just looking at that, you see that your possible rational zeros are plus or minus 1, plus or minus 2, and plus or minus 4. Because you put all those over 1 and that's what you get. All right, now the easiest one of those to do is 1. M equal 1. Okay? And if M is equal to 1, this would be
0.
that's
Oh.
coefficient is 1.
Oh.
That's not a 0 there. I said that was the leading coefficient, and if you don't see it, you understand it to be a 1. Okay? So 1, that would be a 1 plus.
Can I still plug in 1?
Yep.
Plus 3, which is 4.
Four. Is 0. There's an M equal 1. That works for you. Okay?
One question. Why? I don't understand the plus or minus 1, comma, plus or minus 2, comma.
Those are all the possible factors of this constant term here.
Oh, okay.
Okay? And the denominator, all the possible factors of your leading coefficient. That's why I had the circle there. What's your leading coefficient? 1.
Yeah.
Okay? So that's just plus or minus 1. So those are your possibilities. Plus 1 works. Now, you might have, okay, do you remember Descartes' rule of signs?
No.
Okay. All right, Descartes' rule of signs says the number of positive real zeros will be the number of sign changes you have. Plus the plus, that's not a sign change. Plus the minus, one sign change. You only have one real positive zero. You found it already, plus 1. That's it. That was a real zero. You found it. Don't try 2, don't try 4. They're not going to work. Okay? Now, the other half of Descartes' rule of sign was how many possible negative zeros do you have? What you do there, you do f of negative m. Well, that would be minus m cubed plus 3m squared, because if you put a minus 1 in for m, that stays plus. Minus 1 in for this m, it goes to minus. And then minus 4. How many sign changes do you have there? 2. Or 0. Anywhere you do Descartes' rule of signs, whatever number you get, subtract 2 from it. And then keep subtracting until you run out. So this has either 2 or 0 negative real roots. Well, we don't know yet. We haven't tried it. So we're going to try at least one. So let's back up. So 2 or 0 negative real roots. Okay? Now, we know that 1 will work. Remember synthetic division? No. Okay. You put your root there, 1. I like to block it off. Then I put my coefficients in next. My coefficients are 1, 3, no, 0 minus 4. See, you're missing your linear term. So you have to put in a 0 for any term that you're missing.
Yeah.
Then minus 4. Here's my little thing on how to remember that. Okay? You do remember? Okay. What's your maximum n? 3, you better have one more term than that. Gotta have 4. 3 wouldn't work. Gotta have 4. You're missing the 0. Okay? Synthetic division says, now this is again my little rule, you'll never read this in a book anywhere, skip a line, draw a line. Okay?
Yeah.
All right. Then you bring down the 1. Okay, and what you do then is multiply and add. 1 times 1 is 1, add 4. 1 times 4 is 4, add 4. 1 times 4 is 4, add 0. Well, remainder of 0, that meant, yay, you did have 1 as a 0. We already knew that was going to work, but you still had to do your synthetic division. Okay, now what does this represent? Well, notice what we did. We put our coefficients here without putting the m's. Now we put the m's back in, but you reduce by 1. So this will be m squared plus 4m plus 4. Okay? That's your quotient. Set that equal to 0. Can you factor that?
Yes.
How?
M plus 4. M plus 1?
Nope.
4?
Nope.
2.
2
My bad.
times m plus 2, right? Okay? Check it and see. M times m is m squared, plus 2m plus 2m is plus 4m plus 4. Yes, that works. So what are your roots here? Okay. Either m plus 2 is equal to 0 or m plus 2 is equal to 0, right?
Yeah.
Anytime you have a product of 2 or more terms equal to 0, at least one of those got to be 0, right? Well, what does that give?
-2.
Yes. In fact, it's a double root. So m is equal to -2 or m is equal to -2. That's the same thing. Well, sure enough, look at there. There's your -2. The plus 1 was 1, and 2 -2's were 1. So those are your possibilities on your m's, right? So we now go back and write our solutions. Y is equal to e to the mx, where, no, I'm sorry, e to the x, where m is 1, right? Okay. Oh, wait. C1. Yeah. Okay. C1, e to the x, plus C2, e to the, what's your next m?
Oh, -2.
-2x, okay, plus C3, but you can't use e to the -2x again. What do you use for a double root? Oh, yes, you do. X e to the -2x. Remember?
Yeah,
Remember?
I remember.
There you have it. There's your solution. C1 e to the x plus C2 e to the -2x. And since that's a double root, the next one is C3 x e to the -2x. Now, does it matter which order you put those C1, C2? No, it doesn't. You can put the C1 with the e to the minus 2x or with the x, it doesn't matter how you do it, but that's your solution. Okay, let's see what they got. Y is equal to C1 e to the x, good for them, plus C2 e to the minus 2x, great for them, plus C3 x e to the minus 2x, fantastic. That's your solution. All right? Okay. Now, can I erase all that?
Before you erase, what's it called again? That P2?
P over Q thing?
Yeah,
That's called the rational zeros test.
Rational zero.
Because it's a ratio of integers.
Okay.
Okay? Those are all the possible rational zeros you can have. The numerator is all the possible factorizations of your final term, your constant term, and your leading coefficient. Your denominator is all the possible factors of your leading coefficient.
Okay.
Rational zeros test. Okay? Then we use the Clark's rule of signs to say how many zeros we can have. This gives you how many sign changes, how many positive real zeros. As soon as we found that plus 1 will work, don't look for any more pluses, they're not going to happen. Okay, so you eliminate the plus 2 and plus 4. Then you do the Clark's rule of signs here, and you had two sign changes where you do alpha minus m. You have two sign changes. That means you either have 2 or 0 negative real roots. So we don't know if we have, so what we did, we used the one we knew, the 1. This synthetic division, when we got a remainder of 0, we knew what we had left here was a quadratic. 3 terms is quadratic, right? So that quadratic we can factor. Or if we can't factor, we use the quadratic formula. Exactly. Okay? And this one we could factor, and we saw the double root. We knew exactly what it was. E to the minus 2x and x e to the minus 2x. Different coefficients. Okay. Any others? All right. So let's erase all that ink and go to example 4. Written in another format, d4y over dx to the 4th plus 2 d2y over dx squared plus y equals 0. What might we do? Yes, you do. That's just the 4th derivative of y plus 2 times second derivative of y plus y. Higher order linear differential equation with constant coefficients. Oh!
Yeah.
It's just a different format, but it means the same thing.
So is it just let y equals to e to the mx?
You got it. Okay? Y prime would be m e to the mx. Y double prime is equal to m squared e to the mx. Y triple prime would be m cubed e to the mx. And y, sometimes they used to write it like this, Roman numeral. However they write it, okay? In parentheses with a 4, that means the same thing, okay? Doesn't have to be Roman numeral 4. This is m4 e to the mx. That's always going to be the same. So what you can do is just forget about the e to the mx. Just write down what they call the characteristic equation. That's your polynomial. And what would it be in this case?
Hold on, say it again.
Okay. You can write down the e to the, last time you said, let's just take out the e to the mx.
Okay.
And you can do it this time. This time that's not even write it down. Okay? Oh, here I've seen him somewhere before. Where is that? Okay? Somewhere. Okay, Amanda's here. All right. I'm trying to remember. Okay. I've got your research paper. I've got your first test. Did I return it to you? I don't think I did that. Okay. I returned them earlier, but I think it was a day you weren't here. So let me do that. We'll make it even swap, won't we? Yeah, good deal. All right. And that was the second test you just turned in, right? Now, have I given you your third test yet? No, I haven't. Okay, I don't have it run off. I'll run that off right at the end of class, okay? I had not enough copies run off, and I gave Victor his, so I'll have to run off one for y'all. Okay. And we're trying to remember, were you here Monday? Okay, I didn't think so, but I couldn't remember for sure.
He wasn't here?
No. He was trying to cover for you, okay? You can thank him later, okay? However much he charges, okay? All right, okay. All right. I just forgot to write the roll down. What happened, I think you came in late. I just started teaching, and when you came in, I forgot to mark you on the roll. And I think that's what happened. Okay. But I may be wrong. All right, we're in Chapter 4, Higher Order Differential Equations, 4.3, Homogeneous Linear Equations with Constant Coefficients, and we're on Example 4 on page 138. We've written it down here. Were you here enough to know the procedure for these? Okay. So where do we go from here? That's where we're discussing. How much you wanted to write down, how much you wanted to skip.
I'm just going ahead and pull out the E to the next.
Okay. And what?
Say, M to the fourth.
M to the fourth?
Time. I'm going to E to the M next.
Okay.
I'm sorry. I keep messing up on that every time. But I'm sorry. It's M to the fourth power plus 2 M squared plus 1
1
equals 0.
equals 0. Ding, 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 ding. Got it. Okay. Where do we go from here?
We use that rational.
Zeros test. Sounds good to me. Okay, first, before we do anything else, let's use Descartes' rule of signs. How many positive real zeros can that have?
1 or
9, because there are no sign changes. Okay, no sign changes at all. So let's go to our negative real zeros. What would that be? Put in a negative M rather than M.
it'd just be M to the fourth plus 2M squared plus 1. It'd just be something.
How many zeros? Negative real zeros do we have? None. We have no real zeros for this one. Not a single one. So therefore, you're not going to have any rational zeros either, okay? If you have no real zeros, you certainly can't have any rational zeros. So, yeah, what are we going to do then? Because,
I guess do the synthetic division or none.
yeah, but you see, you don't have any roots. You're not going to have any real, roots to that. All right, so we're going to have to guess about complex roots, right? Oh, yeah. So, what might they be? Okay. Well, there is something you can do. Okay. I don't know if you like to substitute and see this or not, but let's see if they substitute. No, they don't. Okay. See if this will work for you. Let's let n equal m squared. Would that be okay? Then what would n squared be? m to the, if n is equal to m squared, you square n, so square root of m squared, and what you get? M to the fourth. Now what you have is n squared plus 2n, right, plus 1 is equal to 0. Would you buy that? Okay. Will that factor? And you may have factored it this way too, but I didn't know if you'd see that as clearly. It didn't seem like y'all were seeing it, so will that how does that factor? N plus 1 times n plus 1 equals 0. Right. So what's your n's? And this one? Okay, they're both -1. But what is m? N is m squared. So m squared is equal to -1. Ew. What does that mean m is? What square gives you -1? It's just not a real number. I. Okay. The I's have it. Okay. Or, how about minus I? Would that work too? Minus I squared would be minus I times minus I, which would be plus I squared, which would be -1 again. So here's what we got. M is equal to plus or minus I. Right? So now your equation is y is equal to e to the ix, let's call it C1 e to the ix plus C2 e to the minus ix. Now those, they usually put capital C's because they're going to change them later. Okay, but this is a double root, right? So that means you're going to have an x in there too, remember? Double root, you do that. How does that go? Do you remember that? All right. If you flip back one page, one piece of paper to page 136, your conjugate complex roots. Okay? All right. Now let's imagine that you had your y to be e to the alpha plus I beta x. Remember that? And then your other one would be e to the alpha minus I beta x, right? Now those both have imaginary pieces in them, but by Euler's formula, what did this become? Y is equal to, and these were capital C's here because they're not the same as what we were on that with a little c. Remember how that went? E to the alpha x times, my pen is really slow, I like to do A cosine beta x plus B cosine beta x. And you see that's what you wind up being. When you have complex roots, you have that. They do C1s and C2s. I do capital A and capital B. It doesn't matter what you do as coefficients as. Okay? In this problem, we don't have any alphas. There is no real part. The M is only imaginary. So then you leave off the alpha part. And what's your possibilities there? The alpha is 0. There is no real part. So then there's e to the 0x is 1. So don't even mess with that. And this gives you and let's go back to C1s, I guess. C1 cosine, and your beta is just plus and minus 1. X plus C2 sine X. Okay, but you have a double root there. So you do C3 X cosine X plus C4 X sine X. Okay, that becomes your thing. Because you see you had a double root here, right?
Oh, okay. I was like,
Yeah. So we're combining your case 2 back on that previous page was repeated real roots, but you could do the same thing with repeated imaginary roots. And then your case 3 was conjugate complex roots, which gave you your sines and cosines. Okay? And your coefficients here are your i's, are your number here, your betas, and that was just 1. Okay? And then you use the x cosine. So let's see what they came up with. Oh, okay, I couldn't find it. It was on the previous page. Y is equal to C1 cosine x plus C2 sine x plus C3 x cosine x plus C4 x sine x. Okay, I just ran out of room at the end. Okay. Now, in example 4, your k was 2. I don't know. I mean, where does the k's come? Oh, yeah, right. Yeah. Okay. How many multiples? What your multiplicity was? Okay. Alpha was 0 and beta was 1. Okay. Now they have a little blurb there as well. How are we doing on time? Okay. On rational roots. Can I erase this? Is that okay? All right. Of course, the most difficult aspect of solving constant coefficient differential equations is finding roots of auxiliary equations of degree greater than 2. Sometimes we can test the auxiliary equation for rational roots. Recall from pre-calculus mathematics, if M1, you got your book? M1 is equal to P over Q is a rational root expressed in lowest terms. There's that rational zeros test. Did you remember ever doing it? I know you didn't take pre-calculus here. Okay. That's what it is for the P is a factor of the constant terms and Q is a factor of the leading. It's just what I just told you. It was maybe right before you came in, but yeah, that's what we got. So, let's do example 5. This thing is aggravating. Okay. 3y triple prime plus 5y double prime plus 10y prime minus 4y is equal to 0. Okay? Where would you begin?
Y equals e to the mx.
Okay. And you want to go through all that, or you want to cut just to the auxiliary equation?
Yeah, let's just jump to the equation.
Okay, and what would that be?
It would be 3 times m cubed e to the m. No, I'm sorry, just m cubed plus 5m squared plus 10m minus 4 equals 0.
But I do want to write it down. Y is equal to e to the mx. So when we get our m's, we know where to put it back in. Okay. So let's have that in there. I didn't mean to cut it out. Now, am I skipping too much? Because I know you weren't here. You see where this is coming from? Okay. All right. What would you try next? Second. Rational zero test will certainly be good in conjunction with Descartes. Yeah, Descartes. Rene Descartes. Descartes. Rene Descartes. Descartes' rule of signs. Descartes was a great French, actually a philosopher as well as a fantastic mathematician. What do we call that? Board over there. Okay. What kind? Okay. It's called the Cartesian coordinate system. You know where that comes from? Rene Descartes. He's the first one to link algebra with geometry. Before they were thought to be two completely separate and different fields, he said you can plot algebraic equations on a two-dimensional graph and get a graphic of them. So the Cartesian coordinate system. Also, I'm guessing most of you probably have heard this. I think, therefore I am. Ever heard that?
I have heard of that.
Okay. He's the one that came up with it. Great philosopher. Okay. I think, therefore I am. Rene Descartes. Pretty good dude. Okay. Okay. Descartes' rule of signs says what?
That there's only
One what?
change of sign.
One change of sign, which is one positive real root. Okay? So keep that in mind. One positive, so irritated. Okay. One positive real root. Because you only have one change of sign. Then what's the next thing we do? Plug in a minus m.
Yeah.
And that gives you
Negative 3m cubed plus 5m squared minus 14m.
that's a 10.
Oh, 10.
Making fun of my writing, I can tell. Okay?
Minus 1.
What does that tell you?
That there is only one.
Change of sign. 2. There's a change of sign. There's another change of sign. So 2, anytime you have a number greater than 1, you subtract 2 from it. So 2 or 0 negative real roots. Remember? 2 or 0 negative real roots. Okay? Solution, whatever you want to call it. Okay, now, I think, let's do our rational zeros test. What would that tell us? Your rational zeros will be of the form P over Q, where P is? Nope. Yeah. All the possible factors of 4, which are plus or minus 1, plus or minus 2, plus or minus 3. No. 4. Okay. Over which is? No, 1 and plus or minus 3. Yeah. 1 will always be 1. Okay? So what does this give us as all our possible rational zeros? List them out. Plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 1 over 3 is 1/3, plus or minus 2/3, 2/3, and plus or minus 4/3. got a lot to check, don't we? Okay. Now the easiest one is 1. Okay, let's see if 1 will work. Okay? You don't have to do synthetic division or anything else. Just plug it in, plug it in. Whatever you put M equal 1 here.
3, 5, 10.
Is that ever going to be equal to 0? No, that would be 18 minus 4 is 14. Not 0. 1's not going to work. Don't even mess with the 1. Okay? Now, second. Okay, you could do a negative 1. That's what I was going to ask. What do you want to go for next? Minus 1 or plus or minus 2? You can do any one of them. Which one you want? Boy, what a glutton for punishment. Okay. He works way too hard. I'm way lazier than that. I like the minus 1. Okay? Goodness gracious. Okay. Now these, I think it's easier to do the synthetic division. Okay? If you want to multiply them out, you can, but synthetic division, I think is pretty good. Let's try minus 1. That goes outside. Remember how to do synthetic division?
Oh, yeah.
How?
It's 3, 5, 0.
That's a 10.
Oh, 10.
You're not missing any terms.
Oh, yeah, that's right. 10. And
Minus 4. Okay. Now, how do you check to make sure you got enough numbers there?
Because it has.
It's got to be 1 more than your maximum 0. I mean, maximum exponent. 3 here, 4 there. Good. You got it. Okay. Then you skip a line, draw a line, and do what?
Drop 3.
Okay. I dropped it. Okay. And what do you get?
5 minus 5.
You multiply.
Oh, yeah. Negative 3. Oh, yeah.
Negative 3,
Which is 2.
2, negative 2, 8. No way. Right? No way you're going to get a 0. Negative 1 didn't work. Watch his 1/3 or 2/3 or whatever he said. What that be the only? Yeah, that'll be disgusting, won't it? Okay, so negative 1 doesn't work, so we'll do away with that and that and that and that and that. Everything else stays the same. What you want to try next?
Try, I guess.
Which?
Oh, 2.
2. Okay, let's try 2. What do you get next?
6.
6. What's that? Add.
It says 10.
Huh? Add. 5 and 6 is 11. You just multiply, add, multiply, add, multiply, add. It's simple. Huh? It's too big too. What do you get? Okay, you get 22, you get 32, you get 64, you get 60. Now the only reason I did this, and I probably could have, the only reason I did this, look at this. That's a positive number, all these are positive numbers. That means you're already past it, okay? You cannot get any more. This is called the upper bound. You passed the upper bound. So that means, Boo gets, okay, we're going to have to go with those fractions. Don't even try plus 4. That's going to get even worse. So now we're going to go to 1/3. Because you know you've got one positive real root, okay? One positive real root. Is that your car alarm? Okay. What's that?
I sometimes sit on my keys and
Oh, I see. Okay. Okay. So now we got to try something less than 2, a positive number less than 2. You know you got one positive real root. Of course, it could be irrational. It may not be rational, but let's try it. So let's try 1/3. Boo hiss, okay? What would that give you? 1.
So I'm a little lost on this one. So do we add?
Add.
Okay, add. So 6.
6.
And that's
2. 12. 4. 0. It did work, didn't it? There's our one and only one positive real root, m equal 1/3. That's what you said to begin with, or was it
He
2/3?
did say that.
All right. Did you know that already, or did you just guess?
I guess because the 1 was going to be too high, and all the numbers greater than 1 is going to be too high.
Right. Good. Good eyes. Okay. So there it is. There's our one positive real root. M equal 1/3. Okay? And what do we have here? What does that represent?
Oh, that represents 3m squared.
Yes, exactly. 3m squared.
Plus 6m minus 12.
Where do you get a minus?
I mean, plus 12.
Plus 12 equals 0. Okay? Now that's a quadratic. Now what's the first thing I'm going to want to do with that quadratic? Say again? I can't hear.
Simplify.
How?
They're all divisible by 3.
Yes.
See written here. Divided by 3, is that what you said? Yeah. Okay, factor out of 3. And that gives you
Oh, m squared
m squared,
plus 2.
m,
Plus 4 equals 0.
okay? Now, 3 can't equal 0, all right, so I'm going to divide it out. So let's look at that one. Do you think you can factor that? If you can, you win the Fields Medal.
No, I don't think.
No, you can't, okay? So what do we do if we can't factor? Quadratic formula. What does that tell you? M is equal to
Minus
2
2 plus or minus square root of 4 minus 4 times 1 times 4 divided by 2 times
2 times 1 is 2, okay. That's equal to minus 2 plus or minus the square root of help me. 12, negative 12, okay, over 2, which is minus 2 plus or minus I. That takes care of the minus 1. Anything else? Okay, you can also pull out another perfect square. What's that? 2. Pull out a 2. And what do you have left? Square root of 3 over 2. But guess what? The 2's can go out, right? They've been dating, okay? So that gives you, your answer is minus 1 plus or minus I root 3. That's what your M is. So 1, okay. Now, let's get back to, and by the way, you have no negative real roots because they're both complex roots, imaginary roots with imaginary parts to So you're down to 0 with negative real roots. Okay. There was a chance the other two real roots could have been, if you had two more, they would have been negative. You don't have them. You couldn't have just one more real root. You'd have had either 2 or 0. You have none. They're all imaginary. So only one real root, that was 1/3, and your other two are this one. So, can we write down our solution? Y is equal to, I'll start, C1 let's get that one in. Okay, let's do these two. Okay. All right. Yeah. Let's do cosine. Okay, if we're going to do cosine, we need something else in front. And we don't have to put it in front, but that's where we usually put it. You have a real part and an imaginary part, don't you? Okay, and what would the real part be? So e to the minus x, right? That's the alpha, times C1 cosine, question mark, say again? Yes, the square root of 3x plus C2, question mark, sine the square root of 3x. Be sure that you write it so you don't think the x is under the square root. Okay, and then your third one was? Say again? C3. 1/3 x. M is 1/3. Now you can write that in any order you wanted to. I would have put this in front, but it's okay. C1 e to the 1/3 x plus e to the minus x. That's from this part, the real part, plus times C2. C2 I would have done cosine square root of 3x plus C3 sine square root of 3x. It doesn't matter which order you put in C. Those are just arbitrary constants. Okay, let's see what they got. Y is equal to C1 e to the x over 3. I put 1/3 x. What's the difference? Okay. Plus e to the minus x, sure enough, times, parentheses, C2 cosine square root of 3x. Square root of 3 is square root ends there, x is outside, plus C3 sine square root of 3x. Perfect. Okay.
One question.
Yes.
When it says e to the negative x, the real numbers.
Say that again.
You know where it says at the bottom? It says negative 1 plus or minus I
Yeah.
3. If that negative 1 were 2, it would have been e to the negative 2.
Okay, is that a 2 or negative 2?
Or just negative 2.
Negative 2, then it would have been a negative 2x there. Has that been a 2 plus or minus 5? It's been e to the 2x. Whatever the real part is, that goes there.
Okay. And you said it was a negative 2, that would make it, so it would have been e to the 2, right?
Okay, if this would have been a negative 2 here, that would have been e to the minus 2x.
Okay.
If that was a 2 here, without a minus sign, that would be e to the 2x.
Okay.
Whatever that is, that's the outside part. Notice it doesn't have an arbitrary coefficient with it. That goes with the sign coefficient. It doesn't matter, but yeah, it does. All right, make sense?
Yeah.
No. Yeah, okay, got it. Okay. I'm afraid it's sad news time, isn't it? I can't see my watch. Yeah, it is. Sorry about that. We didn't get to finish chapter 4. Okay? So, Victor, I hope you're listening. Let me go make your copies. I'm going to end this.